AOPS Volume 1 The Basics number 47. A train x meters long traveling at a constant speed takes 20 seconds from the time it first enters a tunnel 300 meters long until the time it completely emerges from the tunnel. One of the stationary ceiling lights in the tunnel is directly above the train for 10 seconds. Find x. Alright, so we're already given what we need to find, so we don't need to suppose any quantities. And as always, when I'm doing distance problems, always try to give yourself a rough model and representation of what the word problem is describing. And let's say that the light is somewhere right here. So at this very point, the train, when passing through it, is x meters long. So it's traveling at a constant speed. So this has to do with velocity. And when doing it with velocity, it's always good to remember the velocity formula, which is equal to the distance divided by the time. So we're told that when it's traveling at a constant speed, it takes 10 seconds for it to pass through this light. So from the time it first touches to the time where it passes, it will have taken 10 seconds. So the velocity, if we're going to do it relative to this scenario, will be the time for which it took, which is 10 seconds, in the distance. Well, how much of the distance was it when it passed from this point right here to this point right here? Well, when it first entered this light, this very point right here, and from this point he traveled all the way to this distance right here, it would have traveled the length of the train. Think about it. It take the train's length in 10 seconds to travel that period of distance underneath the light. So our first velocity is given by x meters, the train's length, divided by the 10 seconds for which it was underneath the light. That is sufficient details for the velocity of the train since the speed is constant. But we're also given another scenario of how to find velocity, that it takes 20 seconds from the time it first enters the tunnel, 300 meters long, until the time it completely emerges from the tunnel. So it takes it 20 seconds to travel this entire tunnel lengthway, which is 300 meters long. Well, remember our velocity formula. The distance, if we're going to do it relative to the entire length of the tunnel, the distance will be now 300 meters. But how long did it take to travel this 300 meters? And actually, are we really traveling 300 meters relative to this details that we're given? Think about it. When the head of the train first enters the tunnel, the head must first travel the 300-meter distance. And by the time the train is somewhere right here, that the head of the train finished traveling the 300 meters, the tail of the train still has to travel x meters the length of the train. So instead of traveling 300 meters, it must travel 300 meters plus x meters, since the tail still hasn't exited the tunnel yet. The entire train takes 300 plus x meters, not 300 meters, to travel the entire length. And I'm going to repeat this, and that is because the tail hasn't exited the tunnel yet by the time the head has. So we have to add x to 300 divided by the time, which is 20 seconds. And since the velocity of the train is constant, that means that this velocity relative to the time for which it travels the entire tunnel, and this velocity, which has to do with respects to the time underneath a stationary light, must be equal to one another. And since their quantities are the same, which is in meter per second, we can establish this relationship. X over 10 is equal to 300 plus x over 20. Cross multiply and simplify, and we will solve the question. 20x is equal to 3000 plus 10x. Subtract 10x on both sides. 10x is equal to 3000, and if we divide 10 on both sides, x is equal to 300. So meaning that this train is a whopping 300 meters long, the solution to our question.